Hey there, math students. Today we are going to be talking about proportions. Let's go ahead and start with our I can statement. Today, I can identify and solve proportions. All right, so what is a proportion? Well, we're going to get to that in just a second. Let's start with our warm-up questions. When someone says ratio, what should you think? When we say ratio, you should think fraction. A ratio is like a comparison of two numbers, and you can put one on the top and one on the bottom and make a fraction. So a ratio is like a fraction. Now this is just kind of a review two-step equation. Let's solve this. So if you have x over 2 plus 11 equals 7, you got to get that x by itself. So what do we get rid of first, the 2 or the 11? In this case, where we have that small little fraction bar and the fraction bar doesn't go all the way across like under the 11 and everything, in this case you get rid of the 11 first. You're going to get rid of it by subtracting. So those go to 0. You're left with x over 2. And let's see, 7 minus 11 is going to give us negative 4. Now you have x divided by 2 equals negative 4. Let's use the opposite of division to get rid of that 2. So the opposite of division is multiplication. Those are going to cancel out. You're going to be left with x equals negative 8. And if you got that, good work. Let's go on to warm up C. In elementary school, you learned how to change a fraction into another equivalent fraction. Do you remember how? So like if you wanted to change 4/8 into another fraction that still meant the same thing but with different numbers, how would you do it? Well, a nice way to do this one is you might just think about simplifying the fraction. So if you divide both of those numbers by the same number, it looks like they're both divisible by 2 and they're both divisible by 4. We could really go either way to answer this question. Let's divide them both by 4. So 4 divided by 4 equals 1. 8 divided by 4 equals 2. Or what if you had a fraction like 1/3? Can you simplify that anymore? No, you really can't. But what if you were trying to find the greatest common factor or something? What if you wanted to turn that 3 into a 6? You would multiply it by 2 to get a 6. And then what would you have to do to the top? You'd have to multiply it by a 2 also, right? So let's see, 1 times 2 is 2, 3 times 2 is 6. So that's just an example of how you turn one fraction into an equivalent fraction. And then this one became this equivalent fraction. So the question is, how do you do that? And this is the how. You're going to multiply or divide. Go ahead and write this down if you don't have it already. Multiply or divide the top and bottom numbers by the same number. Let me just draw a little box here so you can see that easier. So you're going to multiply or divide the top and the bottom numbers by the same number. Okay, so this next section here where it says find the missing number, that's actually what we're going to be learning to do today. So we're going to skip this part. Now, if you're looking at it and thinking, ooh, wait, I already know how to do this, and some of you certainly may already know how to do this, I want you to still keep watching because I'm going to show you two different ways, and it's possible that at least one of them is new to you. So please stay tuned at least till we get through the bottom of this page. Okay, let's keep going. A proportion is something that sets two ratios equal. You know what? It's an equation. So we've already seen a few proportions on this page. This is a proportion, this is a proportion, and this is a proportion. How do I know they're proportions? Because you have a fraction on one side, well, a fraction on both sides, with an equal sign in the middle. That's what makes that a proportion. You can skip all that stuff that I have crossed out. Let's go to here. If two ratios form a proportional relationship, that is the same as saying they are equivalent fractions. So equivalent fractions. Those are fractions that equal the same amount, even though they might have different numbers. For example, 4/8 and 1/2. Those are the same. They're equivalent. So how do we tell if two fractions form a proportion? Let's take a closer look at the warm-up question. Do you notice any patterns about the numbers and the ratios? Well, that's what we're about to do. So let's keep going over here to example 1. There are several ways to tell when we have a proportion. And the first one, and this is the one that most of you might be familiar with, maybe. We'll see. This first one is called scale factor. Okay, so with scale factor, we can multiply or divide to go from top to top or bottom to bottom. So what am I talking about? Well, it's a lot like what we did here. Let's take a look at this. It looks like we have a blank right here. We need to figure out what number goes in that blank to make an equivalent fraction. Or we could say to complete the proportion. Same thing. So it looks like we're going from this fraction to this one because that's where the blank is. So let's look at the bottom numbers where there aren't any blanks first. How do you go from a 12 to a 3 using either multiplication or division? You're going to divide by 4, right? Because 12 divided by 4 equals 3. So now we know we just have to do the same thing to the top number and we figure out what goes in the blank. So 24 divided by 4 equals 6. So 6 is going to go in that blank. All right, let's look at the next one. This time it looks like the blank is over here on this side, so let's make sure we're going this way. 4 times or divided by what equals 20? 4 times 5 equals 20. So what do we have to do to the 6? We have to also multiply it by 5. Now what is 6 times 5? It is 30, so that's what goes in the blank, and we have completed our proportion. We got one more example here. It looks like the blank is here this time, so let's look at the top numbers, and let's go this way, because we have to figure out what to do to that 27, right? So 15, you multiply or divide by something and get 5. I'm thinking divide by 3. So 15 divided by 3 equals 5. What about 27? Let's divide that also by 3. And you're going to get 9. So 9 will complete that proportion. So that's how you use scale factor. It's a lot like making equivalent fractions, common denominators, simplifying fractions, that kind of thing. What about cross multiplying? I don't know if that's new for you guys or not, but let's talk about it. Cross multiplying is also known as the butterfly method. And apparently some people call it the heart method, although that's new for me. But if that's what you call it, then this is what we're talking about. Now the reason we might call it the butterfly method is because we draw things on it that wind up looking like a butterfly. So let me show you what we're talking about. So it looks like we have a blank right here, right? You can just use an X to represent the blank. Now you're going to cross multiply, which means multiply kind of in a diagonal way. There and there. See, it looks kind of like a cute little butterfly, right? You could just draw the little antennas and like maybe a little smiley face. My 7-year-old puts smiley faces on all his drawings of like bugs and animals. It's so cute. Anyways, I should get back to math. So the butterfly method, once you have your little butterfly drawn, you're just going to take the like where the circles are and write them into an equation. I know that made no sense. Let me show you what I need to do. So you see how the x and the 12 are circled? You're going to multiply those together. So x times 12, you know, really a better way to say x times 12 is just 12x, right? So we're still multiplying the 12 and the x together. Okay, so we took care of that circle. Now we're going to write an equal sign. And now we need to multiply the things in the other circle. 3 times 24. Now, as you can see, we don't have any fractions anymore. We just have a nice simple equation. So let's solve our equation. A calculator might come in handy here. Although I could show you another way to do it without so much calculator, but let's start with the calculator because it works and it is useful. 3 times 24 is 72. So let's just take that right-hand side and make it into a 72. Unfortunately, I look like I'm running out of room here, so let's take our next step up this way. So when you have 12x equals 72, we still need that x by itself. So let's get rid of the 12 by dividing. So we're going to divide both sides by 12. 72 divided by 12, use your calculator if you want to. I know that it's 6, so I'm just going to write x equals 6. Okay, and now if you look up here, you may have already noticed this problem is the same as this problem. We just solved it a different way, and we got the same answer. We got 6 for both. Let's look at another one with the butterfly method. Okay, so where are we going to cross multiply? Where do we draw our butterfly? Around the 6 and the 20, and then the 4 and the blank. So you might want to think of that blank as an X so that you have something to hold that place when you write your equation. So we could do this one first, or we could do that one first. It doesn't matter. I'm going to start with this one. 4 times x, 4x, equals 6 times 20. 6 times 20. Okay, now let's simplify. 4x equals, what is 6 times 20? That's going to be 120 Now you're going to divide both sides by 4 because you got to get that x by itself. And you're going to get x equals 120 divided by 4 should be 30, right? So x equals 30, which is the same thing we got up here with this other method. Okay, one more with the butterfly method. Our blank is down here. This time again, I'm going to write an x in it. And then we've got that way. Now I'm going to show you the special trick this time. You do not have to use this special trick, but it's here for you if you want it. So in this special trick, you still start the same. Let's see, x times 15, I'll write 15x equals 5 times 27. So now this time, instead of going ahead and multiplying these, you're going to leave them spaced out like 5 times 27, and I'll show you what to do next. So divide by 15, that'll just get rid of that there. And of course you have to divide by 15 here as well. And now this time you can kind of simplify the fraction before you do the multiplying up here. What am I talking about? Well, let's divide the top by 5, so that just makes that go away. And let's divide the bottom of it by 5 also. 15 divided by 5 equals 3. Can we do that even more? Yeah, we can. We can divide both of these numbers by 3, can't we? So divide the 3 by 3 and you get a 1. Divide the 27 by 3 and you get a 9. And now you can't simplify that anymore. You're just left with x equals 9 over 1. It may look a little bit messy, so let's write that again. X equals 9 over 1, which is the same thing as to say x equals 9, which is the same thing we got over here. Okay, so you may be thinking at this point that you really like one method over the other, but I definitely encourage you to be able to use both because I'll tell you why. The factor method is faster, but it won't always work as easily. Things don't always go nicely and neatly. And when things aren't quick and easy, the cross-multiplying method is going to work better for you. So make sure you can use both of these methods. Now this next little section, this little baby section here, this is just kind of cool and for fun, but like I said, it's really cool. So let's look at it really quick. So this proportion is just the same thing as these, so we know that the number is 6. And they're saying, do you notice anything about the sum of the numerators and denominators? Okay, here's what they're doing. Like I said, this is cool, so stick with me. 6 plus 3, what does that equal? 9. 24 plus 12, what does that equal? 36. Okay, let's go ahead and do these also. 6 plus 4 equals 10. What was this one? 30. 30 plus 20 equals 50. This one was a 9. 5 plus 9 is 14, and 15 plus 27, I don't know, but we can find out. 42. Okie doke. So what are we talking about here? Well, when we were doing the factor method here, what did we have to multiply or divide by to get from there to there? Looks like we had to divide by 4. Well, what if we did that with the sums? 36 divided by 4 equals 9. Oh my goodness, that worked for the sum too. What about this one? To go from here to here, we had to multiply by 5. Is that going to work with the sums? 10 times 5? That works too. That's kind of crazy. What about this one? You divide by 3 to go from there to there. What about here? I don't know. What is 42 divided by 3? 42 divided by 3 equals, look at that, 14. Beautiful. So I don't know that this is going to be super useful, but it's just one of those cool things that numbers can do. So that is what happens with the sums. Now let's go to example number 2. This is a lot like the first section of your homework. Let me look at that, make sure. Yes, it's a lot like the first section of your homework, like I was saying. So it says determine whether these ratios form a proportion. Show your work or give a reason. So here you need to either use the factor method or use the cross-multiplying or butterfly method. So like in this first one, I would say check and see if anything's jumping out at you where you could use the factor method. For me, I'm looking at those top two numbers thinking 3 times 2 is 6. Okay, so this number times 2 better equal that number or else it's a no. So 7 times 2, does that equal 14? Yes, it does. So they are a proportion. They do equal each other. Oh, sorry about that. Let me turn my alarm off. Okay. They do equal each other, so this would be a yes. And the yes means they do form a proportion. Okay, let's look at this one. Now 4 becoming a 6, there's nothing very obvious that you can multiply there. So I'm going to go with the cross multiplying method. So I'm going to draw my little butterfly. And now I'm going to cross multiply. 4 times 11 equals 44. Now that should equal what the product of these two numbers is. 9 times 6 equals 54. No, that is definitely not equal. So the answer is no, that is not a proportion. Let's look at the last one. Okay, 1 becoming 5.6. Well, you could do 1 times 5.6 if you want. A lot of us don't like working with decimals like that though, so I'm just going to go ahead and show you the butterfly method here. But again, both should work, so you should do what is making more sense to you. 1 times 22.4 equals 22.4. 4 times 5.6, I'm going to ask my calculator. 4 times 5.6 equals 22.4. So is that a yes or a no? That's a yes. Okie dokie. So that's like the first part of your homework, your assignment. And this is like the second part of your assignment. You have to find the value that makes each proportion true. So in other words, what is x going to be equal to? You can use factor method or you can use the cross multiplying. So here I'm looking at this and I'm thinking 7 times 3 equals 21. But you know what, I'm going the wrong way. We kind of need to go from this one to that one because this is where the unknown is. That's where the x is. So instead of times 3, to get from 21 to 7, let's do divided by 3, right? So on top, we're also going to divide by 3. 12 divided by 3 equals 4. So x equals 4. Okay, what about over here? 9, and you want it to become 63. Well, I'm going to say 9 times 7 is 63. Oh, and I'm going the wrong way again. Look at me. So 63 to get to 9, you're just going to have to divide by 7, right? And again, going towards that y, that's the way we need to be going. 49 divided by 7, let's see, that's going to be 7, right? Y equals 7. Okay. Now what about this one? How do you get from 11.2 to 56 using multiplication or division? That I don't know. It's not in my times tables that I learned in elementary school. I don't know about you guys. So I'm going to use the butterfly method. So let's set this up. We're going to do 11.2 times n, which we usually write as 11.2n, equals 13 times 56. I'm going to go ahead and simplify the 13 times 56 with my calculator. It's telling me 728. Okay, 11.2n equals 728. Now we just got to get rid of this 11.2. We're going to get rid of it by dividing both sides by it. So 728 divided by 11.2 gives us 65. And that's all you got to do. So n equals 65. Okay, so now let's move on to this thought question at the bottom of the page and then I'll let you guys go. Why does cross multiplying work? This is kind of cool too. So a lot of times when we're solving equations, we don't like to have numbers in the denominator, and we get rid of them by multiplying by them, right? Like if you wanted to get rid of this 4, we would multiply both sides by 4. And that would get rid of the 4. But what if you also wanted to get rid of the 20? You can multiply both sides by 20 also, right? So I'm going to say times 4 and times 20 on both sides. So what does that do? That means that the 4 crosses out here and the 20 crosses out here. And you're left with 20 times 6 equals 4 times x, which is exactly what you would have gotten if you had cross multiplied. Isn't that crazy? I love that so much. You could solve it from there. We're not going to worry about it. It's the same thing here. What if you have that y in the denominator? If you were solving an equation like that, you'd want that y out of the denominator, and you would do that by multiplying by y. So let's multiply both sides by y. And let's get that 27 out of the denominator also. You're going to multiply both sides by 27. So both sides are being multiplied by y and by 27. Now the y on top and the y on bottom cross out, and the 27 on top and the 27 on bottom cross out. So you're left with 27 times 5 equals 15 times y, 15y. Now, is that the same thing we would have gotten if we had cross multiplied? 27 times 5, 15 times y. Yep, it's totally the same. So that's why cross multiplying works. It's just a nice simple way to think of it. So I'm going to let you work on your assignment. Start at the top. You've got 12 of these questions where you have to see if it's a true proportion or not. And then you've got a few more questions where you're filling in the blank. And you can skip the equation questions at the bottom, so you can just cross those out. Okay, thanks for watching. Bye, guys.